Right now, the United States is reactivating Cold War military bases that have been closed for 20 years. Roosevelt Roads in Puerto Rico, once the largest naval base in the world, is being brought back online. Fighter jets are repositioning. Destroyers are forming blockade patterns in Caribbean waters. And if you understand why this is happening, you'll understand more about modern naval warfare than most people ever learn. This isn't just about one conflict. This is about how geography determines everything in maritime warfare, and why the lessons here apply to every naval flashpoint on Earth.
Let's start with the fundamental question. Why does the Southern Caribbean matter enough to justify all of this? The answer is strategic geography. Look at Venezuela's position on the map. It sits at the intersection of three critical zones: the approaches to the Panama Canal, direct Atlantic access for South American powers, and the island chain from Trinidad through the Lesser Antilles that create natural choke points for controlling sea traffic. Here's what most people miss. If a hostile power establishes permanent bases along the Venezuelan coast with modern anti-ship missiles and submarine facilities, they create what's called an area denial zone. Modern missiles can reach hundreds of miles out to sea. This isn't theoretical. During the Cold War, Cuba played exactly this role, and the U.S. spent enormous resources containing it. The difference now is that today's missiles have far greater range and accuracy than anything available in the 1960s. This is why Roosevelt Roads matters. Modern warships are incredibly capable, but they're dependent on logistics. A destroyer carries 90 missiles, but once those are expended, it needs resupply. Fighter jets need fuel, munitions, and maintenance. Roosevelt Roads provides all of this within striking distance, which means sustained high-tempo operations without vulnerable supply lines stretching back to the mainland. The conversion of Henry Rolson Airport in the U.S. Virgin Islands into a military logistics hub tells the same story. This infrastructure investment signals preparation for sustained operations, not just a temporary show of force.
Let's talk about why modern naval operations require such a complex mix of ships working together. If you've wondered why the Navy doesn't just send one powerful ship, the answer is layered defense and the problem of simultaneous threats. Modern naval warfare centers on missiles, submarines, and aircraft attacking simultaneously from different directions. A single ship can be overwhelmed by saturation attack, where more threats arrive than defensive systems can handle. This is why operations involve multiple specialized ships. Think of it as three defensive layers. The outer layer is detection and early warning. Ticonderoga-class cruisers with Aegis combat systems serve this role, tracking hundreds of targets simultaneously and coordinating responses across the fleet. They're the quarterback, seeing the whole battlefield and directing every player. The middle layer is active defense, shooting down incoming missiles. Destroyers like the Arleigh Burke class carry vertical launch systems with interceptor missiles. Here's the brutal math. An anti-ship missile traveling at twice the speed of sound gives you maybe 60 to 90 seconds from horizon detection to impact. Your systems must identify the threat, calculate an intercept, launch a defensive missile, and guide it to target. No room for error. The inner layer is close-in weapons, rapid-fire cannons as a last-ditch defense when everything else fails. If threats get this close, you're already desperate, which is why outer layers are critical. Now, layer offensive capability on top. These same destroyers carry Tomahawk cruise missiles for land attack, Harpoon anti-ship missiles, and torpedoes for submarines. But each vertical launch cell holds one missile, and you must choose your loadout before deployment. Do you prioritize air defense, land attack, or anti-ship weapons? Once deployed, you're committed. Electronic warfare adds another invisible dimension. Ships jam enemy radar, disrupt communications, and create chaos in the enemy's targeting ability. If the enemy can't communicate or get accurate targeting data, their weapons become far less effective even if launched.
Submarines represent the most misunderstood aspect of modern naval power. Nuclear attack submarines operate on multiple mission types simultaneously. Intelligence gathering is often more important than strike capability. A submarine positions itself in international waters and uses sensitive sonar to monitor everything above and below the surface, tracking ships, monitoring communications, and mapping underwater terrain long before any conflict starts. Modern torpedoes are sophisticated, unmanned underwater vehicles with their own sonar and guidance. The Mark 48 carries over 1,000 pounds of explosive. If it misses, it turns around and hunts again. The kill mechanism isn't just the explosion, but the shock wave that can break a ship's keel from feet away. But torpedoes aren't the primary weapon anymore. Modern attack submarines carry vertical launch systems for Tomahawk cruise missiles, striking land targets hundreds of miles inland while remaining submerged and undetected. A submarine can position offshore, receive satellite targeting data, launch cruise missiles through vertical tubes, and disappear before anyone knows it was there. The real advantage is imposing uncertainty. If an adversary knows submarines are operating nearby but doesn't know where, that forces them to dedicate enormous resources to anti-submarine warfare and constrains their freedom of action. Ships must move in defensive patterns, aircraft get diverted to patrol. The mere presence of submarines, even without firing, changes everything the adversary attempts.
Now, flip the equation. When a weaker force faces a technologically superior adversary, they don't match strengths. They exploit weaknesses and leverage asymmetric advantages. Geography becomes the defender's greatest ally. Dense jungle, mountainous terrain, and complex coastlines with hundreds of islands create enormous challenges for attackers dependent on surveillance and precision targeting. A missile launcher in jungle under camouflage is incredibly difficult to spot from the air. If it fires and immediately moves, it becomes almost impossible to track before it fires again. The coastline creates particular blockade challenges. Countless small harbors and river mouths allow fast boats to hide and dash to sea when surveillance gaps appear. Defenders don't need to defeat a blockade entirely, just create enough gaps to keep some supplies flowing. The numbers game is another asymmetric advantage. Millions of mobilized militia create enormous problems for invading forces. Modern militaries excel at precision operations against military targets, not occupying territory and controlling populations. History shows technologically superior forces achieving military victory but failing strategically because they couldn't control ground with available forces. Long-range drones change asymmetric equations significantly. They don't require sophisticated infrastructure or extensive training. Systems like Iranian-designed Shahed drones can threaten logistics hubs and airports with weapons costing thousands, while defenders spend millions shooting them down. This creates economic asymmetry that affects sustainability.
Modern warfare depends absolutely on knowing where enemy forces are, but achieving that knowledge is harder than people realize. Radar has significant limitations. It struggles with low-altitude targets because of ground clutter and Earth's curvature. Small boats or aircraft flying low become invisible beyond certain distances because radar waves pass overhead. This is why maritime patrol aircraft exist, getting high enough to see over the horizon. Satellites provide different perspectives, but with limitations. Most reconnaissance satellites pass over areas only once or twice daily, imaging only what's visible then. Cloud cover, darkness, and camouflage hide targets. This makes persistent surveillance from aircraft and drones critical for continuous observation. The electromagnetic spectrum becomes a battleground. Both sides intercept communications while protecting their own, detect enemy radar while minimizing detectability, and use jamming while maintaining network connectivity. Actions in the electromagnetic spectrum can be as important as kinetic weapons.
The targeting cycle reveals the complexity. Detecting a target is just the first step. You must identify it, decide if it's legitimate, determine the best weapon, get approval, coordinate to avoid friendly fire, and execute. If the target is mobile, it might move during any step. Time-sensitive targeting requires compressing this cycle from hours to minutes through exceptional command systems.
Here's what this all reveals about modern naval warfare. Technology matters enormously, but geography, logistics, and asymmetric thinking often matter more. The most advanced weapons systems become ineffective without supply chains to sustain them. The best surveillance struggles against defenders who understand terrain. The most powerful fleet faces challenges from adversaries willing to fight unconventionally. The Caribbean situation is like high-stakes chess, where one player has superior pieces, but the other knows every corner of the board. Understanding this dynamic applies far beyond one conflict. It's the framework for understanding every maritime flashpoint from the South China Sea to the Persian Gulf. Geography shapes strategy. Logistics enable operations, and asymmetric advantages can offset technological superiority. That's the real lesson here, and it's one that determines outcomes in every naval conflict.